Hello everyone, welcome to new video. In this video, we're going to learn how to make plots out of the data set. Suppose you have a data of different genotypes and treatments and their yield and the different treatments for different genotypes, and you want to plot it, you want to show in a plot how the data is varying between treatments and between genotypes. So there is various kind of plots. The main kind of plots are like bar plot, box plot, violin plot, dot plot, and the heat map. You can also show in a heat map how the values are differing, how the yields are varying across the treatment and across the genotypes. So before going to how to design, how to plot this kind of plots in R Studio, I'm going to explain what are these plots. So initially, the first plot we are going to learn is box plot. So box plot is like a whisker plot. It's also called as a whisker plot, which shows the median, the quartile 1 and quartile 3. The quartile 2 is the median, and the minimum values and the maximum values. Anything above the minimum and maximum is outliers. And we have for this interquartile range, there is a box, there's a bar for the minimum and maximum, and anything outside minimum and maximum is outlier. So this is called a box plot. It is also called as whisker plot. It shows the range of the whole data and what's the median, the first quartile and the third quartile on the outliers. To get to know about the outliers, this plot is quite very useful. This is called as a box plot. And the next plot is a bar plot. So bar plot is a simple plot. It shows the volume of the quantity of the yield on y-axis, and x-axis is the genotypes or the treatments. And this is the standard error, the positive standard error. You know the standard error, right? Standard error is calculated by standard deviation by square root of n number of genotypes or number of treatments. So this is called standard error bars. Sometimes you also see standard deviation as a error bars. So, but you mostly in the bar plot we use standard errors as a error bar. So this is bar plot, and this is dot plots. It shows the values for each genotype, for each uh, treatment. Suppose each genotype is replicated 3 times or 10 times. So each data set is denoted in the dot. So that's why it's called as dot plot. Suppose each treatment has a different values repeated like multiple times. So each replication is denoted as a dot, the value, and this is called a dot plot. And the next plot is a violin plot. This is quite well, I can sophisticated plot. It shows both the box plot, the box plot, the inside the violin plot there is a box plot, same median, first quartile, third quartile, minimum, maximum, and it also shows, including box plot, it also shows a density plot. So density plot suggests how many times the each value is repeated. The frequency plot. Suppose the value is 200, so 200 times repeated how many times? So it shows a normal distribution curve. It shows a distribution plot or something called probability density function. It shows how the data is distributed. So you can get to know the distribution of the data set, and also all the range median of the data set. So violin plots are quite very useful. So let's go back to the R Studio, and this is the R Studio, and I'm going to set my working directory. Already set my working directory. I'm going to import a data set called data from the workings directory. Browse. Go to data. I'll explain about the data set in just a minute. This is character, and this should be the numeric and import. So this is the same data set which I used for the previous video for calculating post-hoc test on ANOVA. So it has the genotypes. Each genotype is replicated 3 times: G1, 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 G2, G2, G3, G4. And it has the treatments. One is control, treatment 1, treatment 2, treatment 3, and 4 genotypes. For each data set is replicated thrice. So G4 in T3 is replicated thrice, G3 in T3 replicated thrice, G3 in T1 treatment replicated thrice. So each has the 3 different application, and this is the yield, the plot yield, which is later converted into tons per hectare, and this is the yield for each combination. Suppose for G1 genotype for replication 1 in the control 4.38 yield, and G1 for the replication 2 is 4.45. So you can able to calculate standard error from all this thing because it has the 3 replications. So just calculate the standard deviation for this replication and divide it by root 3, the uh, uh, number of observations. So you will get the standard error. And so we got the data set. The column names are labeled as genotype, treatment, and yield. So suppose you want to plot. So you need to download a package called ggplot2. So there is a package called ggplot. You can install ggplot already installed in my RStudio. So I'm just going to open it. This we need to write a code called library. Library ggplot means the package will open. Package is opened, and first we are now going to do the box plot combining all. So we are going to do between treatments, combining all genotypes in one treatment. What's the value in control, what's the value in treatment 1, treatment 2, and treatment 3, combining all the genotypes. So you want to see the effect of treatment across genotypes, combining everything. So combining all is a box plot. So have done already library ggplot, and the code is simple. Ggplot, the data set name is data. Aesthetics, that's x is equal to treatment, the x-axis is treatment, y-axis is yield, and we need to fill based on the treatment. And the geom box plot, we're going to write a box plot, and theme is black and white, bw means black and white, and the x-axis labeling and y-axis labeling. So you just select everything and click Control Enter. So we'll get the box plot here. We've got the box plot. This is control, treatment 1, treatment 2, treatment 3, combining all the genotypes. This is the grind. So you can see there is a proper effect of treatment compared to control. Treatment 1 is significantly different than control. Treatment 2 is significantly different than control. Treatment 3 is significantly different than control. You can see whether it's a significantly different or not by using post hoc test, which I showed in a previous video. And this is the box plot. Suppose you want to do box plots for each genotype. Genotype 1, genotype 2, genotype 3, genotype 4 across treatments. Then the same code is the same code, but you need to add another short code called paste trap and this symbol and genotype. You need to separate each genotype and make it as separately for each genotype. Genotype 1, genotype 2, 3, and 4. Everything is same, and just select everything. Click enter. So you got package. You got plot for each genotype. Genotype 1. Show you genotype 1, genotype 2, genotype 3, and genotype 4. So you got for the each genotype on the osteochondral is showing the treatment as good effect on genotypes of all the genotypes. So just close it. And if you want to do bar plot, there is a package called dplyr. You can, this is called the most basic packages. If you want to do data, you want to play around the data and make different subset of the data. Suppose you want to only have to combine all the genotypes and have a mean values for each treatment, then it can be easily done by package called dplyr. It's called data tangling packages. So you need to do install that packages dplyr. Then after that I already have installed. So open dplyr and I already opened ggplot. Then so bar plot combined. So in this bar plot we are going to plot it combining all the genotypes across different treatments. So we need to first make a data set where um, this is formed a group based on the treatment and combining all the genotypes. So this is a data subsorted as sub data set. This is data pipeline group by treatment. Summarize. We need to have a mean values treatment, the mean value according to each treatment, control mean, treatment 1, treatment 2, treatment 3, treatment 4. And we are also going to calculate standard error. The standard error is standard deviation of the yield divided by square root of n. So we're going to calculate first summary data set. So there will be summary data here. So it shows the control, the whole mean of the all the genotypes, T1 all the genotypes, T2 all the genotypes mean, and the standard error. So we're going to plot this now. So we're going to plot ggplot summary data and the treatment mean fill by treatment, gm bar plot, and this is all like the same size of the plot and width of the plot. The error bar, we need to add error bar, and this is the x-axis and y-axis labels and all the things. Just select everything and control enter. You will get the box plot. So this is the box plot. Control T1, T2, T3, and this is the standard error. And this is what you got. And if you want to change increase the number of x-axis and y-axis, you can add a separate code. It's just a one single line code where you can increase the axis size and everything. And the same thing for bar plot. If you want to do bar plot for each genotype, so see the difference here is a group by treatment, but you need to group by genotype and treatments. So you're making a different data set where each genotype and each treatment had a different data set, and you need to add a facet code again here, facet wrap genotype. So if you select everything, so you get a data set for each genotype, the bar plots. So don't worry about the codes. So you already know what codes is for what thing. If you know the concept of the writing code and what's their meaning of each sentence, then it will be useful for you to write the code you like. Or you can also take help of some the AI stuffs websites, and you can also find out possible codes. And if you want to improve anything, you can also improve it. If you want to add some data on this, suppose if you want to add some data on this control T1, you can also add this. So, and this is for the dot plot. The next is dot plot. The same is geom jitter. The dot plot we use geom jitter. And suppose again the dot plus for the each genotype, same ggplot, treatment yield, color, geom jitter, facet trap. We are going to give dot plot for each genotype. Then there's a theme called black and white. So control select So you get the dot plots for each genotype, and uh, this is how you got the values of values of the dot plots for each genotype. And suppose if you want to do violin plot, and the violin is the code for violin plot is gm violin, and in the violin plot there is also called box plot. So I explained you the violin plot shows always box plot and probability density function. So this is same as ggplot, aesthetic treatment, yield, fill, and gm volume, violin plot. Trim, you no need to do trim. Trim is equal to plols, and geom box plot is the width, and facet drop for each genotype. So just select everything, control enter. So get violin plots for each genotype. Suppose you want to do for combining everything, you just need to remove this code, and you can get for everything. And this is a heat map. Suppose if you want to show for each genotype, for each treatment, what is the value. If you want to show in the heat map function, so you need to first summarize the data set based on different genotype and treatment. So this is the code for that. And then you need to just run the library ggplot and the heat data set. And there's a heat map called geom.tile, different colors, and this is for low and high, red and yellow. So I'm going to paste this all code in the comment box. You can just easily copy and paste and change wherever is required. And you need to change this column names or whatever the column names you have, and you can run it in your own data analysis. And control enter. So you got the heat map. So this is the heat map. This is the heat map showing the more the higher values, the more the red color. So this is having the highest value, and this is having the lowest value. So you can easily get to know which what combination is having higher value and low value. So these are the few plots which you are going to use in most of the analysis. And in the next video, I'm going to show how to do probability density plots, like normal distribution curve. There are also different types of violin plots. Same violin plot, but if you want to use it for large number of genotypes, then you get a proper uh, uh, the distribution. And you can also show two different data set in one violin plot on each side. So I'm going to do this on the next video. And yeah, thank you very much for watching this video, and have a nice day. Take care.